To start off this experiment, we're starting with two 50 milliliter beakers and adding 20 milliliters of deionized water into each beaker and measuring the pH. In the first beaker, we're adding 40 drops of 1 molar HCl in 10 drop increments, measuring the pH after each 10 drops. The first time we measured the initial pH of just the water, we got a pH of 7, and then after adding 10 drops of HCl, there was a drastic drop in the pH, and we measured 1.70. From then, we added 10 more drops, and it was 1.50, and then after 30 drops, it was 1.30, and then after 40 drops, it was 1.10. We then proceeded to use the second beaker that also had 20 milliliters of deionized water and add 40 drops of 1 molar NaOH in 10 drop increments as well. The initial pH of the water was 7, and then there was a drastic increase in the pH after adding 10 drops of NaOH, and it reached up to 12.70, and then after 20 drops it was 12.50, after 30 drops it was 12.30, and after 40 drops, it was 12.10. Part B, we had a 100 milliliter beaker and two 50 milliliter beakers. We added 20 milliliters of 1 molar CH3COOH and 20 milliliters of 1 molar CH3COO and A to the 100 milliliter beaker, and we stirred it. And then we divided that among the two 50 milliliter beakers. That way we had the same pH. In the first beaker, we added 40 drops of 1 molar HCl in 10 drop increments, making sure that we recorded the pH after each 10 drops taken. And then to the second beaker, we added 40 drops of 1 molar NaOH as well in 10 drop increments, making sure to measure the pH after every 10 drops. So, explaining the equation for part A, I just decided to show you the equation after doing 20 drops of HCl. So we took 1 mole of HCl and we used 1 milliliter, and we divided that by 21 milliliters. And we ended up coming with 0.047619. And in order to find the pH, we take the negative log of that number, and then we get a pH of 132. This was for the acid. We also had to do the same equation for the base. However, it's really the exact same equation. So a shortcut would be to use the pH that we got from the HCl measurement and find the pOH, which would be 14 minus that number. However, you can also rewrite it all out. It'll just be the same 1.32. Part B of this equation was a little bit more in depth. So I did the same thing and only looked after 20 drops, and I wrote out the equation, and I'll talk shortly about it. So basically we're trying to find the pH, but in this case we're using CH3COOH and CH3COONA in the same beaker, so we have to basically put it all together into this equation and find the pH. So the final equation is there at the bottom, and we ended up with a pH of 4.71 after the 20 drops.